putting any kind of lecture number for now. This is just one question and then this chapter will be done. So take the question. If you have a surface like this is my normal. We have not done this question, no? This is a mu is equal to root 2, and then at some point it will reflect back. Then you have to plot delta versus I. You have not done this? Great. So let me give you a context of what the question is asking. You have this boundary which separates the two media, and the medias are given. For some angles of I, there will be refraction. Achha, when I say refraction, it's partial refraction and partial reflection. But for most of the time, we only consider refraction. So for some angles, there is refraction. But when you hit this critical angle and you go beyond that, then total internal reflection occurs. If that is the case, then find the deviation in both the cases and try to plot it. Okay, so I will start in 3 minutes at 12:03. This is a good question. Everyone knows how to plot an inverse sine graph and inverse cosine graph, those things. Inverse trigonometric functions is discussed. Their graphs are also discussed. Huh? Yes. Very good. Attempt. Will it be okay if I take the next lecture from 12:05 or maybe 12:10 and then I extend my next 20 minutes? So you can take this 20 minutes more break, but the next 20 minutes can I extend? Because I don't like this at all. जो time pass उधर चल रहा है, it disturbs me a lot. Think about it and then tell me. Rather than 11:50, you can take break till 12:10, and then I will extend by 20 more minutes. So at 1:40, I will let you leave.
Staying full day lunch break.
Lunch break 20 minutes is not sufficient. You eat, na? You can't eat in 20 minutes. What are you eating?
Why don't you ask each other the teacher? Like you can come in the second class and Sanisha will come in the third class.
If it is okay with you, then tell me later. Yes.
Go beat one day, the rest of it. You beat us, sir. You also beat them.
I can't do it now. Let them grow 1 month, 2 months. Then everything will happen. नहीं कर सकता. I have talked about it. नहीं कर सकते. ठीक है? Any answers for this? Just if I vote right now, how many of you would say yes for this? The first break till 12:10. You are getting 20 minutes more than others. If you want, you can even eat it at that break. Nobody? I said 2, 3.
You can
1,
exchange
2.
periods.
पूरा अच्छे से करो. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 people. And how many of you don't want this? This is minority.
India minority.
That seems minority to me. I mean, my vote counts as 10. Yeah. We will see. Can I start with the question then? Did you get any plot? I think the TIR plot will be much more simpler. Anyways, I'm starting, it's already 12:05. So, I have to find the critical angle first. Now, so from 0 to critical angle, it will refract. From critical angle till 90 degree, it will reflect. Yeah? So, what is the critical angle here? Theta c is equal to sine inverse of mu rarer by mu denser, I think. And that will be sine inverse 1 by root 2. What is that value? So from 0 to 45 degree, what will happen? 0 degree to 45 degree. Refraction occurs. Then what is the deviation when refraction occurs? Then can you see this extension? Is it focused?
Yes.
Can you see the extension? This is the extension. Na? Achha, by the way, if this is angle I, then this is angle I. Then what is the deviation?
R minus I.
R minus I. So what do you get then? Deviation delta as, let me call it delta 1. That's R minus I. But what is R? How to find R? How to find a relationship between R and I? Then tell me what will it be? Batao. It will be root 2 into sine I is equal to 1 into sine R. But then what is R? R is sine inverse of root 2 sine I. So I found my R in terms of I. Now I can plot. I have only a one function. Sine inverse of root 2 sine I minus I. Now we can plot this because I found my delta in terms of I. This is the first function. What can be the second function? That's why I asked you, do you know how to plot sine inverse graphs? Now tell me from 45 to 90 degree. 45 to 90 degree. What is the deviation? Batao. TIR will occur, na? TIR will occur, so this is delta now. Delta 2. This was delta 1. Can you tell me how to find delta 2? Anybody? Delta 2 is what? That's 180 minus 2i, na?
Yes.
Yes? That's delta 2. So delta 2 is 180 degree minus 2i. Achha, by the way, these are actually the standard formulas for refraction and reflection. I did not give them to you because you can do it yourself. But anyways, we discussed in my problem. Now let me plot. I found my delta as a function of I na? Here as well and here as well. Now let's try to plot. Delta versus I. This is 45 degree. This is 90 degree. This is 0 degree. From 45 degree to 90 degree, what does it look like? What kind of equation does it look like?
Straight line.
It's a straight line with what slope? Minus 2. Can you recognize it's a straight line? It looks to me like y equal to mx plus c. Where what is c? 180 degree and what is m? So minus 2. A line like this or a line like this.
Going down.
Down.
It's a line like this. It's a negative slope. So that means you will have one of the graphs. Half of the graph is like this. Acha, where will it cut the when 45 degree? Then what is the deviation value? When I equal to 45 degrees, then what is the deviation value?
90.
90.
Delta 2 equal to 180 minus 90. That's 90. So where will it cut it? 90 degree. Is it okay? Now I have to plot this thing, and this is very formidable. But how to plot it now? Maybe I can talk about the 2 points. Now what are the 2 points? These 2 points, ये 45 and 40. 0 and 45. What is the value of the function at 0? When I equal to 0, what is delta?
I was 0.
What is
Zero.
that? 0? So your function is 0 at 0. What about at 45? Can somebody tell me at 45? Do it in your head.
45.
It's 45? So can you see that this graph will cut here? So there's a discontinuity in the graph. Huh? There's a discontinuity. How will the graph look like? ऐसे. Now here you have to know कि how the sine inverse graph look like. So do you know that?
Some like this.
ऐसा कुछ तो रहता है ना? ये pi by 2, ये minus pi by 2, sine inverse x, ये x, and the graph is something like ऐसा कुछ है ना? So how? अच्छा, by the way, there is a minus I as well. Huh? Then the graph will actually look like this. Okay. You can plot it if you want. Take some in between values and try to plot. Good. This was a delta versus I graph for the given medium. Is it okay? What will occur here? From 45 to 90? VIR. And from 0 to 45? Refraction. And this is how the plot looks like. It's a discontinuous graph. Good. Now that we are done with this, take a new page. We will start with a new chapter. And we will not start with wave optics. I forgot that there is something else that you must know. That's called wave motion, the whole chapter. And I thought you must have studied in 11th standard, but no. Syllabus here is different than what I have studied. So I will have to teach in 12th now. So let's do that. Wave motion. Is it done?
No.
Take a new page. So we are starting our discussion on wave motion today. And what is the lecture number?
1.
I don't want to be. Yeah, this is बोलना चाहिए क्या बोलना चाहिए? What is this?
It's at 12:15, sir. After 12:15.
So at 12:15 I should start.
Should be right.
Should be random. Lecture क्या है? Date क्या?
22.
Let me scroll around. Definition and terminologies. So let's start with that. So wave motion is a chapter, and we'll try to understand what is a wave. If you remember, when I started with ray optics, I said that ray optics is just a subset of what actually the whole optics is. It's a subset of wave optics. Once you understand waves, it's just a better way to actually visualize things. Nothing more than that. The actual thing is wave optics. So before starting with that, we have to understand what is a wave, what are the kinds of wave that exist, and all the description. Okay? That's why we are studying this chapter before that. Now what is a wave? How will I define it? This is how I am going to define it. A disturbance that carries energy and momentum from one point of medium to another. This is how we are going to define a wave. What is a wave to us? It's a disturbance basically. And what does a disturbance carries? Some energy and momentum. Let's try to understand it bit by bit. Have you ever seen these ponds or lakes maybe where the water is still? Yes? And then you throw a rock or maybe a pebble, and then what happens? The whole medium gets disturbed. It's now moving back, flailing like this, and then some waves are also moving away, no? Yes? What happened to the medium? It got disturbed. The whole thing is now moving. You know, how is that moving? Those disturbances are moving. Yes or no? What are they carrying now?
Energy.
They are carrying energy and momentum. And when I say energy, meaning what? The whole medium consists of particles. Huh? The particles, maybe they were having some energy initially, but then when I throw it this, the particle starts moving up and back. You know? Basically, you gain some kind of kinetic energy. Yes or no? See, the thing actually carries energy. Now, what about momentum? How can I say momentum? Have you ever seen you have ships and then huge waves comes and then breaks the ship's basements? Yes, have you ever seen this? How can that happen? Only when you apply a force, no? Only then can you break something. So that means the whole waves, the water waves, were carrying some kind of force. That's why they were able to do that, right? And what is force? Change in momentum by change in time. So basically they are carrying momentum, right? So they are carrying momentum as they move from one point to other, and they are carrying energy as well. And they are disturbances that passes from one point of medium to other. That is how we are going to define a wave. Is there any problem in this? Good. Now that we know what is a wave, a little bit of picture, now there will be classifications, many classifications. Some you may have heard about. So classification of waves. How many kinds of waves are there? The first classification that I will do is based on dimension, whether the wave motion is occurring in 1D, 2D or 3D. Whether the wave motion is occurring in 1D, 2D and 3D, I am making a classification. What can be an example in which the wave is only moving in one direction? Maybe your friend is having the one end of a rope, and then you have another end of a rope, and then you jerk it like this. What happens? A wave moves. Huh? In what direction? Only along x-axis. Only along what direction it moves? Yes, so it's a wave which is moving in one direction, one dimension. What can be an example of 2D motion? Huh? Yes. Water waves. Water waves can be considered as XY surface, no? And the waves move in this XY surface. So that can be an example of 2D wave. What can be an example of 3D wave? Electromagnetic waves. You have not studied this, but when you will study the whole electromagnetic theory, at the end you will study about electromagnetic waves. That's a separate chapter. There you will study that electric vectors actually oscillate in one direction, magnetic vectors in another direction, and the whole wave moves in another direction. So it's a whole 3D thing. Okay? So I'm just writing that as an example. You will understand it much later. Okay. So 1D, write with me. So when wave motion occurs,
Sir, and what is radial?
1 minute. Let me complete this statement. You know, one dimension. An example would be a jerk given to a rope whose one end, a jerk given to one end of the rope, one end of rope, then one end is fixed. Okay? Let me write this as well and then let me compare it out. When wave motion occurs in 2 dimensions, can I just skip that and tell you the example?
Yes.
Example is whatever it is. And this can be example electromagnetic waves, and I will use a shorthand EM waves from now onwards. Please understand it's electromagnetic. Yes, you were saying something.
So waves, how are they doing it? Are they supposed to be 3D because they move in all the directions?
Yes.
So how is it moving?
How does it move in all 3 directions? That's what I
It
just.
moves in all 3 directions, right?
It
So how is it to be here?
What? This water wave? Water wave is occurring in 2D surface पे चल रहा है ना?
On the surface, but when it comes up, it's going along the Z X and
Where is the motion occurring? Don't worry about that up and down. तो इसमें भी बोल सकता हूँ कि the whole motion is like this, but then the particle oscillates. I'm not talking about the particle. I'm talking about the wave. It's moving in one direction. Here it's moving in 2 dimensions. Yes. Good. So this is classification of wave based on the dimension in which the motion is occurring. There can be other classifications as well that you have already studied, maybe something called as transverse wave and longitudinal waves. Have you heard these terms?
Yeah.
सुना है ना कभी ना कभी तो? Transverse and longitudinal waves. Now understand this. When a disturbance, when there is no disturbance, you can assume that particles are still, no? They are not actually still, they vibrate, but let's assume they are still. When there is a disturbance in the medium, then what will the particle do? They start oscillating back and forth about their mean position. Okay? When the particle starts oscillating, then there can be 2 ways in which the particle can oscillate. Maybe the wave is moving like this and the particle starts oscillating like this, perpendicular to the wave motion, or maybe the particle starts oscillating like this, parallel to the wave motion. And based on that, we make the distinction. So when the disturbance moves through a medium, it oscillates the particles. And based on what kind of oscillations is occurring, we have 2 kinds of waves. Transverse and longitudinal. So let's say the wave motion is occurring like this. This is the direction of wave motion. This is the direction of wave motion. And now how are the particles oscillating? They are oscillating like this, back and forth about their mean position. Particles oscillate about their mean position. Okay? perpendicular. Is it perpendicular? It is perpendicular, no? What about the other? What can be another possibility?
Parallel.
Maybe they oscillate like this. Particles oscillate parallel wave motion about mean position. Is it okay? Remember, let me tell you this one thing. Even though the particles are oscillating, when a wave moves from one point to another point, the particles do not go from one point to another. They keep oscillating about their mean position. They do not go from one point to another. What moves?
Yes.
Wave moves, not the particle. Please remember this. Is it okay? It's like this. If you have still water, you throw a pebble, what will the particles start doing? They start oscillating about their mean position up and down. They don't move. The water molecules that they are oscillating, they are not moving. It's a wave that is going forward and forward. Is it okay? Please remember this. This is very important. Okay. This is the classification based on what is the direction of wave motion and what is the direction of particle oscillation. Then there can be another classification. बहुत सारे हैं. Third one is whether you need a medium or not. See, up until now, what I have been talking about wave, you may think कि obviously a wave is something which is making the particles oscillate and then it is moving forward. Na? So it's like this. If you want a picture, it's like this. इधर ये source है, the particles are like this. ये इसको oscillate कराना चल के, it started oscillating like this. Then it's the neighboring particle starts oscillating. Then the neighboring particle, then the neighboring particle, and then the neighboring particle. And what will you see? You will see the envelope. The envelope looks like this. So what kind of wave it is? Maybe some sine wave or cosine wave. And this is what you see. Yes or no? So you may think that for wave to move, you need particles, na? Only then wave can move. But that's not true. That's not in general true. We will talk about it in electromagnetic waves. There are some other waves as well which do not need particles at all. And those are called non-mechanical waves. So distinction here, एक और distinction है कि mechanical. हाँ बोलो.
If two uniform particles are oscillating or vibrating, is it necessary that both are vibrating with same extent, like same velocity and all?
Same?
Velocity, like up to a same extent, like both are.
No, not necessarily at all. One of them may be moving like this, one of them may be moving like this.
On what factor does that depend?
I will derive an equation for it, and please understand, even this can increase, this can decrease. ठीक है? अरे वेव जब मूव करते जब ऐसे पॉइंट में डालते हो, then how does the wave go? ऐसे ऐसे आगे चलते रहते हैं ना? Is it the same every time? No, कभी-कभी ऐसे भी है ना? After some time it fades away ना? So this keeps on decreasing as well. That can happen as well. So the particles are oscillating because there was a disturbance. As the disturbance is going away and away, the particle loses that oscillation and then they come to rest again. Yes or no? Great. So mechanical or non-mechanical waves? So mechanical wave is a wave which needs a medium. For propagation. You understand the meaning of propagation, na?
Yes.
Basically wave motion. And what is a non-mechanical wave? Does not need a medium for propagation. What can be an example of a mechanical wave? Sound waves. And don't worry about it, we have a dedicated chapter for sound waves. So we'll talk about sound waves a lot. And then we have a dedicated chapter for this example as well. What is the example here? Light or electromagnetic waves. So we'll study all of it, don't worry. I'm just giving a very, very broad view right now. So we'll study all of it. No, it does not. Light can even pass through vacuum. Vacuum is not a medium. There is nothing inside vacuum. It's funny that statement in itself is actually also not correct. Vacuum has something, but anyways, so this is mechanical and non-mechanical waves. Now that we have some kinds of distinctions, let's study a very, very general wave, any wave which is traveling. Now there can be even more specific classifications. There can be a wave which is traveling, which is moving. That is the whole chapter, wave ka motion. There can be a wave which is not moving at all. And that's called a standing wave or stationary wave. We have another chapter of that, so don't worry about that as well. सब एक एक करके पढ़ेंगे, ठीक है? For now we will study only traveling wave. So equation of a traveling wave. Equation of a traveling wave. Now understand this. You have a picture in your head. How will the wave move? When particles oscillate in the medium. Yeah? As the disturbance moves, the particles keep oscillating. Na? So let's say you have a. Let me give you one more picture. Let's say you have a motion like this. Particles are oscillating like this. So how will the wave look like? Aisa kuch na? It will look like this. As these particles are oscillating, the wave is actually carried like an envelope. It's going up and up like this. Okay? Good. If I want to find the value of what is the how should I describe the wave? If I can find the value of this displacement, at all points, then I can find a function, and that function describes my wave. And how will I find that function? What does it depend on? See, this wave is moving now. So after some time, maybe it will be here. Then the value will change. Yes or no?
Yeah.
So the function is a function of time. It depends on time because the wave is moving. It also depends ki where is my particle located. If I am talking about this point, where is तो मेरा displacement इतना है. If I am talking about this point, तो मेरा displacement इतना है. So if I know the position of the particle as well as the time if I am specifying, then I can find the value of the y. अरे ये y तुम लोग पढ़ते हैं SHM में पढ़े थे क्या ऐसा y? A sin kx. तो कुछ पढ़ा था? So y represented what? A wave
Displacement.
And how do you find that wave? By specifying the value of x. What is the value of x here? The position of the particle. The particle is oscillating. How big it oscillates? If it oscillates a little, then you will find that wave value. Are you understanding whatever I am saying? Achha. So let's say, so in general, y will be a function of x comma t. Does it make sense to you? What is x? The position of the particle. What is time? T, that's time. Position of particle. And what is t? Time. And what does this y represent? This describes my wave. Describes the wave. Are you understanding whatever I am saying? Should I say it once more? See. Let's say there are many particles. I am taking a very specific example just for your visualization. कि ऐसा मेरा wave है. This is how my wave looks like. अच्छा, this wave keeps on moving, na? Keeps on moving with time. So this wave will be maybe somewhere here after some time. Yes or no? When I write y, you remember that y equal to a sin kx. In SHM we used to write this. Then what does this y represent? This value. Yes or no?
Yes.
This value. If I know all the values, then can I plot the graph? If I can plot the graph, then basically I know my function. Yes? So to find the value of y, I need to first fix the time. Let's say I am fixing the time. I have to get कि एक time पे I am looking at the graph. Let's say I fix my time, my time is like this. Now how to find the value of y? At different positions, the value of y is different. Now what do the positions correspond to? These are the position of particle. Yes or no? So for every given position of particle, I am getting different value of y. So what does my y depend on? It depends on position of particle. It also depends on time. Because as time passes, this also moves. So that value will change. Yes or no? Are you understanding now? Great. So my f is a function of, or my y is a function of x comma t. Good. F is a function. Function पर नहीं पढ़ा है. अभी वो function मैंने कोई ये general लिख रहा हूँ बस. I'm writing in general. I don't know what will the function look like. Maybe that function is sin kx. Maybe that's e power kx. Maybe that's ln of kx. I don't know the function. I'm just saying that there is a dependence. Is it okay? Good. अब this y, if it really wants to explain a wave, it has to follow these three conditions. The conditions, let me write it. Conditions for y to represent a valid traveling wave. The conditions are a very first condition, so I think everyone can understand that the function should be single value. If I give a value of x and a value of t, तो मुझे दो different values of y नहीं मिलना चाहिए. I should only get one y. Does it make sense? Single valued होना चाहिए function. F or y should be single valued for given x and t. Is it okay? Should be single value. The second thing is, have you ever seen waves that are broken like this? Broken like this, or maybe discontinuous waves? You don't find such things, huh? You find a continuous wave. That means the slope should be continuous.
Yes.
So the slope, acha, by the way, this is a function of two variables, na? So the slope will be partial derivative or total derivative? The partial derivatives. Yeah, everyone knows partial derivatives? So del y by del x, this is the first derivative, and del y by del t. These are basically the slopes, must be continuous. Basically means your graph is not breaking anyway. Then there is a third condition which ये थोड़ा out of nowhere लगेगा, but we will derive even this equation. There is something called as wave equation. y must satisfy the wave equation. What is the wave equation? The wave equation is something like this. Del 2y by del t2 is b square del 2y by del x2. This is my wave equation. Those are second order partial derivatives. And that v is called the velocity of the velocity or speed of the wave. Okay? Velocity or speed of the wave. It might look like a little out of nowhere I gave you this equation, but we will try to derive it for a very special case later. Okay? For now, just keep it as it is. The thing is, your y must satisfy this equation, this second order differential equation. It's a second order differential equation, no? Differential equation. It's a partial differential equation actually. These are the conditions that the y must follow to be a valid.
So is speed uniform throughout the wave?
Is speed uniform throughout what?
Wave.
It may depend on the medium. If you remember that as we go from one medium to another medium, even the speed of light was changing. So it depends on the medium. Okay?
So if it is changing, then what value of speed will we keep there?
What value of what?
What value of speed will we keep there? If the
Don't worry about that for now. We will only be talking about homogeneous and isotropic mediums for most of our discussion. Homogeneous and isotropic meaning that mu is same everywhere. The refractive index is same, not the refractive index, but rather the medium will not change the velocity anyway, basically. Okay? Good. If your y actually satisfies all these equations, then it reduces to one form. If y satisfies all three conditions, then अच्छा then function form becomes, what does the function form become? Don't talk, I'm still taking a lecture.
speed of the wave will depend on the displacement of the particles, right?
No, it does not. Don't. When we will make actually quantitative discussions now, when I actually derive some formulas, then you ask me this again. Okay? Don't get confused between the particle commotion and the wave commotion. Please.
It depends on how quick the next particle moves with respect to this particle. Because that's how the waves move.
Let's have a discussion on it later. Okay? Ask me this again. Write this somewhere. Then the function becomes actually something like this. Ax plus or minus bt. And how can you, so actually initially we had a very general function where we said okay, it only depends on x comma t. But now I am saying it will take the form ax plus or minus bt. And what does it mean? A very simple example would be 5 sine 4x minus 2t, ax plus or minus bt. Or maybe 5 e power 2x minus 3t. Or plus or minus, whatever. Do you understand? This is how my function will look like. If this is the way the function is said, then it's a valid function. But still you will have to check the conditions always. Only then make a conclusion. Okay? Let me give you some examples and then let's try to do it. Okay? Example. If y equal equal to x minus vt the whole square, then check whether y represents a wave or not. Check the conditions and give me the answer. Give me 2 minutes to do it. What will you check? All the 3 conditions. Basically, the third condition will seal the deal. चलो जल्दी जल्दी हाथ चलाओ. Check, I'm coming in 2 minutes. Did you find it to be a valid wave function? That y is also called a wave function, huh? So let me write it. Please write it. Wave function. Anybody got the answer? Should I start checking myself? What simple exercise है ये तो? So I have to take the derivatives. I think this is single value. This looks to me like single value, and also the derivatives are going to be continuous. Then what about the del y by del x? That will be 2x minus bt
Yes.
plus. What about del 2y by del x? That will be 2. Is there any problem in this? Please wait. What about del y by del t? Del y by del t is 2x minus vt minus v. That will be minus 2xv plus 2xv square t. क्या चीज?
X minus vt is a constant function.
Who told you that? You know now how to make that. I just skipped it through. तुम लोग को partial derivative लेना आता है ना?
Yes, sir.
Apply the chain rule and then do it.
Yes, sir.
Del 2y by del t2 कितना आ रहा है? That's the first term is 0 plus 2xv square आ रहा है. And x कहाँ से आ गया in the second term? X नहीं है ना? This looks like 2v square. Is it following? Follows the differential equation. Na? What was the differential equation? That
D2
del 2 y by del t2 e square del 2 x by del 2 del x2. ये सही है. तो yes, I think this is correct. LHS 2v square, RHS भी 2v square आ रहा है.
Yes.
अच्छा, by the way, what is that v? I wrote that, na?
Yes, sir. Velocity of the wave.
That is the velocity of the wave. In general, if you really want to find what is the velocity, a very special, simple thing would be actually to take this. So I should have written this before. How to check what is the velocity of the wave. A way in which you can find it is You put this ax plus or minus bt as a constant. That is a constant actually, but how should I explain how it is at a constant? X, and if you remember, a sin kx या फिर minus phi ऐसा पढ़ा है क्या?
Yes, sir.
What does this phi represent?
The wave
maybe
function.
ये पढ़ा है आप लोगों ने. ये तो पढ़ा है ना?
Yes, sir. The phi is
What does the phi represent?
the wave function.
It's a phase. How one of the wave, if it lags or leads the other wave, no? That is what the phase is. This is actually another phase as well, basically. I will talk about it later. This is called a spatial phase, and the other is called a temporal phase. They plus or minus that is constant. Ax plus minus bt is a constant actually. And if you differentiate this, then you will get a dx plus or minus b dt equal to 0. But what is dx by dt? That's basically minus plus b by a.
Yes.
Can you see that? Please check.
Yeah.
Minus plus or plus minus उल्टा हो जाएगा. Minus plus, or you can even write, if you want to remember, this is the velocity of the wave. This is minus of
Both means
no coefficient of. देखो अगर उसमें तुम लोग को दिमाग नहीं लगाना है तो ये याद रखना. Velocity is minus of coefficient of time divided by coefficient of x. Then what is the velocity here? Can you check? What is the velocity of this thing? That's basically v. So that v represents the velocity. If we did not know earlier, then you can directly say it now. ठीक है? अच्छा, just because a letter v is given does not automatically means its velocity. है? So थोड़ा cautiously करना. ठीक है? Can I give more examples to check? Can you try that? So let me give some more examples. That is in that book. But it's a problematic book. Let's say if just by looking at that, can you tell me? अच्छा एक और चीज मुझे बताना चाहिए कि if y is equal to e power ax minus bt, this is given, then what is the velocity of the wave here?
B by A.
Can you tell me?
B by A.
That's b by a, huh? Is that a positive quantity? Let's assume a and b are zero, greater than 0.
It's positive.
Then what will you
Positive.
find? b equal to minus of minus b by a. So that's b by a. This is greater than 0. So the wave is traveling along positive x direction? Yes?
Yes.
Wave travels along positive x direction. Let me give you another thing. What if your y is e power ax plus bt? Can you tell me what should be the b?
Minus B by A.
Should be minus b by a. So wave is traveling in the negative x direction, not this time. What about y equal to minus ax plus bt?
B by A.
B by A.
Should be positive x
Positive.
direction. Now what about the other one? Y equal to e power minus ax minus bt?
Negative.
B by
B. Negative B
Negative
by A.
direction.
Negative direction, है ना? So if the signs are same, if the signs with a and b are same, then in which direction is it moving?
Negative.
In the negative direction. If the signs are different, then it's
Positive.
moving in positive. You can have a mental note like this. Okay? Also, you can even check. What about here? B is equal equal to, this will be b by a, na?
Yes.
And what about here? B will be equal to minus b by a. Is there any problem in this? These are very simple things, huh? I need to add some examples. Can you pause it and then I need to look at some examples? At least attempt one of them and take other as homework and tell me whether it's a valid weight function or not. चलो नैतिक हाथ चलाओ.
First year.
They came to room number 3. पैसा दिया. फिर कब देने के में कब?
Went on.
Right features. Anybody has the same right feature? Maybe we can. Those are right. They are successful. I should not say this. This will go on YouTube. Attempt the question. First one is not a valid weight function.
It is. It is.
How many of you say it is? How many of you say it's not? Minority. I will have to check. So, for the first weight function, we have y is 1 by x plus vt. अच्छा, just for fun.
अरे लेट्स का साइकिल्स बंडी में रखना लो